All right. Very different from following yesterday's, almost the same. We have more functional groups. I didn't even change the title. It's functional groups part 2. So it's just a whole bunch more functional groups. As far as naming them goes, we're only going to name the small ones. These aren't going to be part of huge branching chains. The stuff from before all these fancy things, those are the ones that you're going to have the large branching chains with. These are going to be somewhat small. Most of what you're going to be working with these kinds of chemicals are identifying the different types because they're very, honestly, kind of similar. They look a lot the same. So determining between the two is most of what we're going to work with today. It is the 7th of March today. 7. And the first one on the group is, I think, alphabetically first. It's an aldehyde. So we say this is an aldehyde. They have a C double bonded with an O group on the end. So at the very end of this particular hydrocarbon chain, there is a C double bonded O at the very end. And so the way we write this is we write the R. Do we remember what the R stands for from the last lesson? It just is your hydrocarbon chain. Any length of chain you want to have, that's our just standard one. And we write it like this. We write it CHO. So we write it this way specifically to distance itself from something that has the same number of atoms that it's an alcohol. So it's not an alcohol because it has a double bond in it. And so this is the CH and then O, not the CO then H. That's the main difference with this particular way of writing it. And if I draw it structurally, you can see that it's definitely not an alcohol. So if I draw it, I put the R here, we have a carbon here, we get this here, and we put an H there. So it's similar, but definitely structurally different because the H isn't stuck to the O, the H is stuck to the carbon. So I skipped a blank, and that's how we name them. It names with a AL ending. So these are methanol, ethanol, and pentanol. You really have to fight your own personal accent and say them very, very affected. So it's the difference between an alcohol is an all and an aldehyde is an al. They're very, very close. So they're very, very close. So we have to draw them a little bit. So they get measured from their parent chain that's included in that C double bonded O. So when I'm going to draw a few of these, there's plenty of room for this one. We can draw this one C double bonded to O with H's on both sides. This is methanol. Very similar. We're going to do H3C, C double bonded to O, and an H. So this is my ethanol group. I've got my parent chain would be this particular parent chain. That's the 2 carbons for the parent chain there. Pentanol, I jumped up a little bit, and we're going to go into the line drawings because they are easier. Let's see if I can count. I like to count from the OHs because that's easier. I've got this one here, and I put the H here. So this one here is a carbon. So the first carbon's there. I'm going to branch down from there. So 1, 2, 3, 4, 5. So it's 5 carbons in this way. So this is my line diagram for my 5 carbon chain as I draw my little snaky loop around this one. All right, and so when we're identifying this particular functional group, we're looking for this thing. So this is my functional aldehyde there. So if you see the C, double bonded O, right to an H, that's aldehyde. That's the particular aldehyde that we get. You may have seen this one. The first one you probably experienced, especially if you're in biology class. This is formaldehyde. So this is also known as formaldehyde. This was also the same as the methanoic acid, was also called formic acid. It's an older way of saying a one carbon group. Has this formic kind of styling to it. It's just an older name, and it's not as universal, so we will always be using the methanol name. But this is also known as formaldehyde. It's used as a preservative. Most of the things you dissect are kept in formaldehyde so they don't decompose. And that's that awful smell that all the dissections you have, they smell like the formaldehyde is where they're keeping it. So that's the bad smell of cutting up biology stuff. It's formaldehyde. Yes, but probably not that one, though. All right, ketones are up next. They are almost aldehydes, but they are... Oops, let me put the right color on. They are a C double bonded O in the middle. In the middle of a carbon chain. So they get the... Now, careful with this one. This is going to be very important for you to listen to and not read. Because if I write it down, what do you say? It's not one, it's own. It's own. So it sounds like... Let me try this. Spelling. Sounds like own. So it sounds like own when you say it. So my two examples here, I have propanone and 3-hexanone. So that's how they're said out loud. But they're written like the word is one is spelled. Because English is a problem. Like, there's no reason in English where this should be said as one. That's silly. It's just wrong. That's silliness. Meanwhile, let's do all the important things that aren't me getting mad at English class. This is R1, again, CO, and then R2. So it's in the middle of a carbon chain. So I got a carbon chain here, stuck to this, double bonded to the O, back to even more carbon chain. Yeah, that's them. Sorry? Oh, good. Ask questions, please, because I'm just rattling off these words and definitions. So, propanone is a good one. If you notice, the propanone doesn't have a number because there's only one way to draw propanone properly. It does sound silly. I will draw my O double bonded to C. And so that's where I have to start. And I know I'm going to have carbons on each side. So I have to put a carbon here and a carbon here. And I'm done. That's all of them. I've used up all three. And so there's nothing else we can do here. I can write it this way. That way it looks good. So this is the propanone particular one. So where we have the next one, we have hexanone, but we have to put a number on it because where on the hex chain, we have to put the double bonded O on the 3. So I'm going to start by drawing my 6 hexane chain. Oops, excuse me. All spun around there like this. We're going to get 1, 2, 3, 4, 5, 6. Right. And on carbon 3, which I think is going to work out to be this one. Doesn't matter what you do it. I like it going up, so I'll go 1, 2, 3 on this one. But many of you also probably put it down here, which is fine. But it's on 3, right? It's on 1, 2, 3, 4, 5, 6. It's a 6 carbon chain. And your ketone piece is on carbon number 3. So this is 3-hexanone. I could make 2 hexanone. Can I make 1 hexanone? No, what would 1 hexanone be? What's the one before called? It's an aldehyde. So what would I call a hexanone but put on number 1? What would the name of that particular thing be? Hexanal. Yep. So you say al, like the name is aldehyde, not aldehyde, and so it's an al. We say it like that way, not all, because all sounds like alcohol. So you try to say al with a really awkward accent. So yeah, like al, like a guy down the street is al. Ester. So this is an ether. It's an oxygen joining two hydrocarbon chains. So has an oxygen, oops, not ugly green, beautiful blue, and oxygen. Join two hydrocarbon chains. They are joined with the oxy prefix, so we say oxy. Several ethers have anesthetic properties. Ethoxyethane was used as a hospital ether. Hospital ethers were used as anesthetics, which means to put you asleep for surgeries, etc. So to knock you out so you don't feel them cutting off your arm. The downside is these ethers had damaging effects on your brain, so we don't use them anymore. Sure, it's fine to use once in a while, but they have some long-lasting effects that we don't like anymore, so they are not used. A different kind of compound, like varieties of these compounds, specifically not ethoxyethane, because that one was a little poison. So, I don't know. It's very complicated. Like anesthesiologists go to school for a very long time because their particular concentration and which chemicals to use for which kinds of people, for which length of procedures, is a whole field of medicine that's well beyond my pay grade here in Chemistry 11. We can do R1 joined to O joined to R2, which is the same as R1, O, R2. They're the same because the condensed structures have to be separated by the O. You can't just throw an O in the middle of it. Yeah, it's the same. Just one has a better bend in it to show the proper bend of an oxygen bond. Has that 109-degree angle like water does. So it's going to have that kind of kink in the chain as opposed to a more straight line. That's all. Ethoxyethane has two on each side. So 1, 2, O, 1, 2. Very boring. So this is ethoxyethane. So it's really just one side group, other side group. Now, there's no way of doing this like in another way. So methoxypropane is going to look like 1, O, 1, 2, 1, 2. Is that it? No, 1, 2, 3. There it is. So that's my 1, then 1, 2, 3. Is there something called a propoxymethane? No, you put the bigger one at the end like we normally do, but because this is just easily mirrored, there isn't like any other way to do it. So you just put the smaller one goes first. I'll just write that down here so it's included in the notes. Smaller group first. That's the entire rules for those. Amines. Amines. So yes, it said amine. Amines are nitrogen-based compounds. So nitrogen. Those of you that are expert levels in your Lewis diagrams, you guys remember what Lewis diagrams are? They're the ones with all the dots. So letters and dots. How many bonds does nitrogen like to have? How many bonds does a nitrogen like to have? Both got it. It's 3. 3 bonds. This is a great time to point out. Look at our table. How many does carbon want? How many does oxygen want? 2. Where's nitrogen in relation to that? In between. So it likes 3. So it's 4, 3, 2, 1, and then our noble gases of 0. Amines, the compounds, contain this NH2 group. So amines are something called an organic base. And react really well with acids. So we call these things, they have amino prefixes. as a group, or if they are a parent chain, they get the amine ending. So it's pretty easy. Amines get to be called amines. It's very boring. We're going to do R with NH2. We can do, or fancy, if we're doing all the shapes, we can do this shape for hi.
What's the difference between a prefix and a suffix?
Prefix goes first, and a suffix goes last. So if your parent chain has an NH2 group in it, it will have this amine ending, like methylamine would have a 1 carbon on it. It'll be carbon, nitrogen, H2. It'll be CH3NH2. Would be methylamine. CH3CH2 NH2 would be ethylamine. But if you have like an amino group of a carbon stuck to a big chain, you might have like aminomethyl. What?
No, what are the dots?
Those are your lone pairs. Remember dot diagrams? You would do the dots around. What? It's a lone pair or group, so you don't put anything there. It means like a space. It's already a full bonding pair for the nitrogen not, right?
I don't know that.
Yeah. No, but they hold up a space. So they take up a space, which is why nitrogen has 3 spots and carbon has 4. So, it's a good question. Record. Positive kinetic. We can do multiple hydrocarbon chains. Multiple hydrocarbon chain. So we can add, like in addition to 1 R group, we can do 2 R groups with an H. So this is also a different amine. And we could also put, all 3 could be carbon groups. It could be R1 to R2, stuck to R3. We can put, nitrogen can be the middle of 3 chains. Even more annoying, we can put a cycle around it. This is also an amine. Yeah, so it's like a cyclohexane, but one of the carbons is a nitrogen group. It can even be this ugly thing. It can be as part of one of the benzene rings, right? It can be one of the benzenes in a benzene ring. So this is also a different kind of amine.
What would you call that?
Honestly, no clue. And I think this particular one, well, let me rephrase that. I have forgotten, and it's not part of the lesson, so I didn't remember it. So I think that's a more accurate one.
Would it be like a benzene?
No, it has, so, and we're going to look at naming these lovely things. Ethyl is 2 carbon again. So we're going to try to draw ethylamine. So we're going to draw 1, 2 carbons here, and then draw an N there, and H2. And that's it. Ethylamine. Very exciting, right? Ethylamine. And pentane. So pentane's my parent chain, and I have 1 amino group on the pentane at carbon 2. So I can draw my pentane structure. 1, 2, 3, 4, 5. So I've got pentane here, and on carbon 2, I will stick an NH2 group. So an amino group stuck to a pentane chain. Yes?
You have to put the A.
This really silly group container. it has this, the condensed form of this is awful. It'll look better when I draw the shapes. It is a CONH2 group. So it's basically an amino group stuck to a carboxylic group. So, and they are also able to have multiples around them. Multiple hydrocarbon chains around the nitrogen. So this CONH2 group is terrible in its condensed form here, but when I draw it, hopefully it'll make a little more sense. I'm going to draw a C double bonded to an O stuck to an N. In this case, this is NH2, and this can be any other chain it wants. So specifically what I'm trying to show is this is the amide chunk. So this CO and N kind of combination here, this is the chunk that does the amide thing. And we can replace one of the H's with another R group. We can do that. So we're going to do the same idea here, but N and then another R group. 1, 2, and then an H group. And you can kind of guess what the last one will be. All of the H's are going to go away, and all of them are going to get R groups. So we're going to get an R group here. We're going to do R1, C double bonded to O down to N, and that's R and R2 and 3 in this case. So this is the common factor here, and this is here. So this is the same idea, and since this is in your double bonded N thing, these will always be parent chains in this case. So this will always be, your amide will always end up prioritizing into a parent chain. You will never have an amide group stuck to something else. That would get ridiculous really quickly. So we're going to draw these reasonably small amides. So ethanamide, which is ridiculous, but an ethanamide is just a 2-carbon chain with this amide group stuck on the end. So if I put my, wrong color, C double bonded to O to N and an H2, I'm just going to get an H3, a methyl group here on the end. So I just have my 2-carbon parent chain here. This is my ethane chunk, and then the amide goes on the end. So we can do this the other direction too. In this drawing, I'm going to start with my amide, and so just like how I drew the methyl group, quote, backwards, just because it shows where things connect better, I'm going to draw my amino group backwards. So I'm going to write H2N, bonded to carbon, double bonded to O, and then I can start counting for the rest of my carbons, right? So I already have 1. I need 5 total, so I need 4 more carbons. I would go carbon, 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 and then 1 more carbon in this case. So that's a 5. This will be pentanamide. They are really silly when you try to say them out loud usually, which is why they're mostly for labels on things. They're mostly to be read. They're not really for saying out loud. And this would have all sorts of different pieces stuck to it like this. The way I've drawn it, but that'll work. That'll cover all the different things. The most important thing will not be naming the giant branch structures. We're going to be looking at identifying the functional groups, as we're calling them, in big structures. Because big structures are very actually common in our life and chemistry in general. These organic compounds tend to make really big things because our bodies make these really complicated things, and then we make chemicals and drugs to try to interact with those really big things, and so we have to make big molecules so they interact with other big molecules, or replace big molecules, or block really big molecules. And so they do the medical things that we want them to do. So I've got a variety of, for lack of a better word, I got all these drugs here, and we're going to identify the functional group on them. So First, we're going to identify our functional groups on this particular thing, and then we'll see if anyone knows what the names of these particular things are. There's almost no reason you should. They're just kind of fun facts at this point. So let's take a look at some functional groups. Do we see any ones that stand out to you? Yeah, Pepper. Sorry? The benzene. So the benzene ring is here. And so you can either call this benzene or aromatic. These are both descriptions of this particular cycle. They tend to show up as the 3 double-bonded structures just because that's the way people print these molecules. So when I steal this image from the internet, it looks like this. It doesn't come with a circle in it. When you're drawing it, the circle is easier to draw for like by hand when you're sketching it with a pencil. But when they print them on the computers, the double bond structures tend to look better. So they're just doing that. Any other groups you see that make sense? Recognizing them from today's and the previous day's lesson. Yes. There is no alcohol here. So the alcohol, it's kind of almost an alcohol, but because it's stuck to something else, it's actually something else. So it's this whole piece here is one of the functional groups with the double bonded O structure in there. What is that one called? All together there. So that's a tricky one with the alcohols. The alcohol has to be stuck to only a hydrocarbon chain. If it's stuck to this carboxylic group, that was a hint to what the name is called. It's a carboxylic acid, but since those are the organic acid species, we can shorthand this to just acid. Because I don't want to spell carboxylic all day. So just acid by itself covers it. And there's one more group in here. Can you see that? That's showing up okay, I think. This group in here is also something. What's this particular one called? The double O's in it. It is Tylenol.
Really?
Yes, specifically acetaminophen.
That was crazy.
That was an amazing guess. First try. Acetaminophen is this particular molecule, is the acetaminophen molecule. Bold choices. You saw I had a little bit of a trend going there. Double the pain meds right there. And as you can see, these are both pain medications. You can see they're reasonably similar shaped, right? These are both painkillers, and so they have similar shapes. They're going to do similar things in your body. All right, let's do a few of these. It's just this one that might be the one you guys didn't get. Tend to we ask for like just a straight double bond is one. It's not part of a benzene. It's not part of anything else. It's an alkene, or you can just write, as I am, a lazy person, double bond. This is a lazy person's double bond. What else do you guys want me to circle? Who's first? A benzene. You get to say the benzene first. That one's over here. We've got a benzene. There are 2 amines. I feel like a Wheel of Fortune here where there's 2 amines. And I get to spin these around. That's an amine. Amine is there. Another amine. There's an amide as well. Amide is this thing here. Amide. All right, that's all the groups I want you to identify in this particular molecule. Guesses on this particular drug? It's not. Those are the same, but no, it's not one of that one. I will give you another hint. This is not medicine. This is LSD. This is the LSD molecule. Yeah. That's the LSD molecule. There's no shortage of these. I have so many of these. Let's do the next one. We don't dibenzene. There are two different benzenes, which is correct. That's a benzene and that's a benzene. Great. It's nothing. It could say they're dibenzenes, but like the problem here would be identifying your parent chain. It's like, I don't know. It stops working when they're this big. It kind of stops working. Okay, what other groups do you want me to circle? An amide, which is this one. And the amine is on this one. So I'm actually going to erase that one and make them different colors for any poor person that has to read this later. So this is amine. And this one is amide. But they match. I didn't write the benzene in. Oh, I see. From the previous question. I see. But at least they match the word. So the word matches the color. All right. Now we get our great drug list. Great. That's the end of this.